So this was a question I posed for discussion in the discussion groups, and the question was, why do microwave ovens have turntables? And a few people did respond, and the responses most common was so that the food cooked evenly, which is absolutely true. That is why they have turntables, to make them swirl around in a circle and make the heat distribution more even. Let's put that in context with what we've been learning about standing waves. So a microwave oven emits microwaves, and to get the maximum amount of energy, it emits standing waves. So we want the big constructive interference as much as we can to get the biggest amount of energy. So if we asked what those waves look like, let's see if we can draw them in the microwave. So we get a standing wave that probably looks something like this. So there's one of the waves. Let's just draw the other half of that wave. So inside your microwave, when it's heating up your food, you get standing microwaves. The places where you have the antinodes, so these spots right here, the antinodes, that's where there's always constructive interference. In this place, it gets really hot. This is where it cooks the most. The places where we have the nodes, there's no energy right there. So right here at the nodes, it's always destructive energy, so the microwaves don't come together. If there's no cooking energy, no heat energy, right there, it stays cold. So that's why when you heat stuff up, you get hot spots and cold spots if you don't stir it or make sure it revolves around thoroughly. So that explains why we have the turntables, to make the heating more evenly. So here's something I'm going to suggest that you try at home. This is certainly something that's doable. And this might be fun for you to try. This is, of course, optional. You don't have to do it for credit, but it is a pretty neat little project. And I would ask, can you use your microwave oven to measure the speed of an electromagnetic wave? Like we discussed when we started electromagnetic waves, microwaves are an electromagnetic wave. What we know about electromagnetic waves is they do all travel with the same speed c. So if we can use our microwave oven to calculate the speed, then we do know what to compare it to. We know that it should turn out to be 3 times 10 to the 8 meters per second. So I'll give you some clues on what you could do. Most microwaves, they operate at around 2500 megahertz. And if you look at your own particular microwave, on the back of it, there should be a sticker and it would say the frequency. So the frequency of microwaves is about 2500 microwaves. Your particular microwave will have it stamped on the back. So you can get a good estimate of what the frequency is. That'll be accurate to within a few hertz, certainly. The next thing you can do is you can take your turntable out, so you can put something in the microwave and have it not rotate. So that's the first thing. What I would suggest is that maybe you just scramble up a couple of eggs. So eggs will spread out, and then let it cook for a little while it's not rotating. Keep an eye on it. Then as it cooks, check on it every so often. Eventually you should be able to see it come out with some cooked spots and some raw spots. Where it's cooked, you know you have antinodes. Where it's not cooked, you know you have nodes. So if you use that idea and see your distance between the nodes and the antinodes, you should be able to sort out the wavelength. And then you could just measure that with a ruler. You won't be super accurate, but you might get pretty close, within a couple centimeters. So then with your frequency you read off the back, with your wavelength you measure, you can just figure out that V equals F lambda. See how close you get with your value of C. So I'm going to suggest you give it a shot. By all means, try this at home, and then come back to the discussion groups and see if you can compare with some of the other people in the class and see what they got.